This is part 2 of our vintage Electrohome 662E series radio. In part 1, we changed out the paper condensers that had gone bad and found that the audio output transformer had failed. In this one, I'm going to put a replacement audio output transformer in and see if we can get some sound out of it, and we'll replace the rest of the caps and see if we can make this thing work. Coming right up. Okay, I'm back working on this old beast again. And what I've got here is I've got a salvaged output transformer. This is a proper vacuum tube output transformer, speaker output. This one's actually from a push-pull, and this is a single-ended, so I should be able to get by with just not using the center tap here for it. It should work. We're going to give it a try. I found a universal single-ended transformer, but at about $100 for the transformer, I figured I would try a salvage one first. So first thing we'll do is we'll just connect this up to the speaker and see if this speaker even works. I'm competing now with them grinding up the road up the street. They're putting a new water main in, so hopefully I'll be able to get over the noise. When we look at the way that this thing's wired, it's quite unique. Like, these are the two wires that went to the primary of the transformer. This other red wire was connected to the actual shield. If you notice, the other wires that come in here, one goes, well, both of these go up to this large electromagnet, but one side of the electromagnet, there's a winding that comes back. There's actually two wires that go up here, the white and the black. One of the wires comes back down to one side of the voice coil. The other wire comes down to the other side of the voice coil. Or sorry, correction, one side comes down to this lug here, which goes through the secondary of the audio output transformer, and the secondary comes back here. So we've got one winding going through the voice coil, or through the magnet on the back. It is then going through the voice coil, back through the secondary, and returning. It's quite the little setup here. We'll make sure that the voice coil isn't burned on the speaker before we go any further. So here's the voice coil, and it is 1.9 ohms, so we know that it's good. And it looks like we have a black and a white wire here, so we should have continuity. I think I already tested this anyway, but let's just make sure that we've got continuity through that electromagnet. Okay, this is a split primary. So I should be able to, I think, probably just use the full primary and not use the center tap at all. So I'm just going to hook this up with some jumper leads, and we'll test this radio out and see whether we get any sound. So I'll plug in the speaker plug first. And we'll get some leads. And we're just going to connect it up just like the other one was. Probably should even hook up this ground wire. I'm just going to, I'll use another jumper for that. Just for now. I think this is a ground wire. It's a red wire, but it was grounded to the speaker frame, so I have to assume that that was a ground wire. So here's my primary leads. Leave the center tap unconnected, and then I'll use a couple of yellow wires just to jump to the speaker from the secondary terminals here. And we'll plug this thing in and see if we can make any noise with it. Okay, power on. I don't know if the power's on the radio yet or not. Let's make sure. I'll use the power knob. I think that's it there. We'll see if anything's lighting up on here. I hear something. I hear something. Will it tune anything? I need to put an antenna on this thing. sound. Let's see if we can get better sound. Let's see if I can get another station here. What am I listening to?
It's 200,000. He kept changing it to 500,000, to a million, then to 500. And now it's $10.45 million. You want to be part of that, you can go to ucaring.com/JJWatt. $10.45 million now being raised for JJ Watt.
It works.
In his
What I'm going to do now is I haven't changed the electrolytics in this thing yet either, and I'm going to do that. I'm going to put some new electrolytics in here. But I'm going to mount this transformer, wire it up, and then we'll change some electrolytics. But now at least I know I've got this thing's going to work. So I've mounted the transformer. This one's a lot bigger than the other one, so I've just had it mounted at an angle here, but that's okay. It's not going to hurt anything. Nothing's touching, nothing's shorting out. We'll just reconnect the speaker wires here. Now I'm just gonna do this temporary, so I'm not going to bother putting heat shrink on this just yet. I'll just throw some tape after I'm gonna solder the wires, but I'm just gonna put some tape on them for now. Okay, that will temporarily connect everything. We'll just put some tape around these connections for now. Put that back on there. Okay, to change out these caps, and say somebody's already bridged this one that's on the orange wire from this, so we're going to remove this Philco old cap, and we'll replace it with, I've got a couple 33 microfarad at 450. These are actually high temperature caps. They'll be just fine for this application. So I'm just going to remove these two that are part of this big can here and replace it. One of them's between the brown, the orange and the black wire here that you can't see, but I can. That's one cap, and this one's been bridged across it, and the other one is from here down to here. So I'll have to figure out how to hook that up. Anyway, we'll get that one installed, and that'll bridge out those two. I'm still trying to figure out what the heck to do with this big multi-cap. Some of them have already been replaced, it looks like, because there's leads that are cut off, so someone's actually changed out some of those in the past. Oh, they've hooked them up too, but they've been swapped out. Some of them have anyway. It's got to figure out what values they are, and we'll try and swap that one out as well. Looks like these are the two ground leads here, so these other two leads here I think are probably the only two that are still in operation, or maybe there's three of them in here. You'll see what this thing's hooked up to. Anyway, looks like there was 3 or 4 caps in this before. There's a couple that have been cut off. There's 2 leads down here, one here and one here, that have been cut off on this. Anyway, let's get to replacing a new capacitor in place of this big one, this can on the other side. I'm gonna just hook it up to the chassis down here, and we'll bridge in the ground wire. So we'll take off that red wire, and we'll connect the positive up to this mess that's down here. this other one goes to ground, so I'm just going to connect a wire for ground. I'll just reuse another wire from something else to connect my ground wire up to this. Okay, that's one replaced. I'll just kind of dress this so that it's not touching anything. Not going to touch anything that could get warm. The other one, I'm going to replace this big Philco cap here. We'll just cut this one out and replace it, and cut the orange wire that's going to the original two-stage cap that was in there. So actually this one here goes up to, this is the main filter, it goes up to here. So I'm wondering, probably maybe better to attach this capacitor right up to here and then bring a ground wire back down. That might be the way to do it, and that way eliminate this wire here. So we'll take that wire off. We'll use that one as the wire to return. So this green wire here, this is coming from the power transformer. So we're just going to clip off this white wire, which is what went down to the filter, and try and clean up this mess a bit. And I'll connect my positive side to this capacitor right up here on the chassis, right at this connector, right to the transformer basically. And I can take the negative side of this capacitor and just kind of tuck this out of the way here. These other wires out of the way. Negative side of this capacitor I'm going to take back to this other wire that goes down and connects right to here. So the negative side of that wire is going to go right down to here. And this other orange wire that you guys see here, you guys see me cutting off, that's what went to the cap that I'm now disconnecting. And we're going to get rid of this other one here as well, as that one is not needed. My camera seems to have slipped on me. So we'll just take that out. I'm going to connect this wire up here to my new negative for my new filter. And we've gone to a larger filter in capacity size. Okay, I think that's got that taken care of. I could actually pull this other can cap out if desired. You'll have to excuse my daughter if you heard her just dropping the F-bomb in the background there. I think the cat just bit her. I have a sneaking suspicion that that was what that outburst was about. She just got back from the vet. And let's put it this way, the cats are not in a very friendly mood right now. Okay, power up. Got an antenna hooked up to this thing.
Houston and Texas tied at 1. The White Sox leading Minnesota 2-1. I'm Ralph Irvin. This ain't reality TV. FS1 on your television. Go to foxsports.com for details.
What I'm curious is I'm going to try the other tap on that transformer and see if it's any louder. Okay, I just tried the other tap on the transformer. And we'll see whether we get any more volume out of this one.
Just after the bottom of the hour. We'll also visit with Jenny Brentis of the MMQB here shortly. I'll let you know that the phone number to be part of the show is 877-996-6369. 877-996-6369. You can weigh in on our poll question at richeisenshow.com. Follow on Twitter at Rich Eisen Show. My Twitter handle is at Heller Sports. At Heller Sports. We work our way through a Thursday, and we're talking all things NFL for a few minutes here. We welcome in Jenny Brentis of
And the haze could last right into next week, at least through Tuesday.
This afternoon, you are paying to cross the Port Mann and Golden Ears bridges for the last time before tolls come off. But you better make sure any outstanding bills are settled. News 1130's Marcella Bernardo reports fees are only being charged until midnight. That's what John Horgan announced last Friday when he made good on a promise which helped him become premier.
You shouldn't have to pay tolls because of where you live in Maple Ridge or Surrey, south of the Fraser River.
I don't have an antenna on this thing, so that makes a difference, right?
And then, these additional player protections. There was some initial confusion, and I think rightly so, over exactly, what the violation of the rule was, because he didn't, there was... The section from 5 to 3.
Capilano Audi in the North Shore Auto Mall.
That is so good.
To go into Port Coquitlam. No delays for the pair. You can check out AM 17 Metro Vancouver at AM 730 traffic. Good afternoon, I'm Yvonne Shell with your global sky tracker weather forecast. A bit of a break if you're not deep, but it is going to ramp up once again. The long weekend. Friday, 23 if you're by the water, underneath the sunshine.
I think I gotta clean some switches.
27 degrees. Even hotter for Saturday, 25 inland at 30 degrees. Some of the hotter days, though, for the long.
We'll just get some cleaner in there and clean that switch. It's actually sounding pretty good for an 80-year-old radio. This thing comes from 1936. 37, somewhere in there. They only made this chassis for 2 years. So I think for a piece that's that old, doing as little as I had to do, change some capacitors, change the transformer, it's actually doing pretty good. Switch I'm going to clean is just the shortwave AM switch, and I'm going to just use some neutral. This is classic neutral. This is not the stuff that you buy today. This is stuff that's from the I think this can probably was made in probably the 1970s. It's the old stuff. Maybe early 80s, before they banned all the good chemicals. So this is actually the good stuff that they used to make. I don't know what band I'm on.
Kids, keep up with this crisis. We need more than the kits. The kits are something that you can use after the event.
Ah, I got a lot of noise from the lights in here, fluorescent lights.
Never seen.
Not much down there. Should be a sports station here at 650.
Naloxone kit
690.
is in tunnel report,
730.
starting with the downtown.
980 from right here. Yeah.
This point.
1040.
They're really. Oh, here it is.
1130.
11:30. Vancouver's breaking news.
1410. Should be a Chinese station there.
Children.com. 19 plus deployment. Know your limits. Play within it.
It's working. Wonder if
I'm Leon McLaren.
I don't think I'll hear anything on shortwave at all, because first of all I don't have an antenna other than a piece of wire that's 2 feet long, but let's just see if by chance it can actually get anything. Probably not going to hear much on shortwave right now because it's daytime. Yeah, I don't think shortwave we're going to hear anything, but certainly AM. It's a tough switch to turn. At least with the wooden knobs on it, it'll be easy to turn. As you can hear, this thing's working.
Flash 650. Oh, this slightly cooler weather has been a welcome change for the second half of the week, but our meteorologist Russ Lacade is warning of more record-breaking heat in the longer-range picture. And if I'm to believe what I see on these charts, early September may well be...
It's sounding great. I think I can safely say it's done. I'm still going to try and figure out what the heck that big multi-cap is in the back, because it would be nice to change that thing. But I've changed all the other paper ones that have gone bad, and I've changed the electrolytics. This one that you see in the back here now is completely disconnected. There's no energy at all going to this. I've just left it in the cabinet. Even though somebody else removed its neighbor at some point, I've left that one in there, but everything else is original. All the tubes are all original. Rectifier output, all the tubes are original on this thing. And you know, for an 80-year-old radio, this thing's actually sounding pretty good.
Construction are all first class.
I'm getting some pretty good volume out of this thing too.
Waterfront property like this in the lower mainland.
I'd like to hook this thing up to a long wire antenna. Maybe I'll do that. I've got a box of old Cat 3 wire. I should go grab some of that and just string it out and throw it out in the front yard. And I'll wait till it gets dark, and then we'll try and see whether this thing will pick up anything on shortwave. I bet it will once the sun goes down and the signals start to come in. So it's nighttime now, and I've hooked up an outdoor antenna. Let's see if I can get anything on the shortwave band. Here's shortwave here. Here comes the noise level. I think I'm going to
The voice of Seahawks Nation.
I think I'm going to not worry about the shortwave. This switch is kind of really touchy, and I cleaned it, but it seems to be still pretty flaky. It cuts in and out, but it only seems to do it in the shortwave position. There's nothing really on shortwave that this thing's going to pull in anyway. There's not a heck of a lot of broadcasting on shortwave these days. Even when I had the large antenna on it, I was able to get a couple little stations down here, but really there is not a lot on shortwave like there used to be. So it works, but I think I'll advise the guy that owns it that maybe we just leave it as an AM radio, and if he's going to use this thing, I think he wants it more for the collector's value anyway. But
quarterback battle, Austin Davis on that final game-winning touchdown.
I'm still going to try and find that replacement for that big cap that's got 3 caps in it. So maybe we'll measure that first and see if I can replace those, and then we'll get it in the cabinet. Okay, I've identified those capacitors here that's in that multi. It's a 1 microfarad 200 volt right here, another 1 microfarad 200 volt here, one more. Looks like this is a could be a 0.1 or a 1 200 volt. So on the screen to ground, just a filter, and one more. This one looks like it could be 25 microfarads 200 volts. That looks like the 4 caps that are part of this multi. I'm just going to put the meter on here and see if I can measure the capacitance of them and confirm that that's what they really are. Okay, I think this might be a 2.5, not a 25. It's hard to just measure this one here and see. Yeah, it could be 2.5 microfarads. Let's just check this. That's right here. 2.1. Okay, that's probably a 2.5. So I think that I've identified what these are. Now I'm just going to see if I can find some. They're all just bypass caps to ground, so I don't think they're all that critical, but they haven't shorted. Just going to reattach this thing for now, and we'll see if I can find something to bridge them with. But one thing I did notice is that the way that this speaker is wired, the actual audio not only goes through the voice coil, but it also modulates the magnet. And it looks to be that they modulate the magnet, the electromagnet, in the opposite polarity because the magnet is going through the transformer. Therefore, if the transformer is connected backwards, it will have a negative effect on the speaker output because the magnetic field should go the opposite direction. It should push the electromagnet the opposite polarity of the voice coil, and if it's wired backwards, it'll be counterproductive. It'll be canceling the signal. So I'm going to reverse the secondary and see if that increases the volume of this thing. And where I get to that is if you look at right down here, okay, the voice coil. This is the transformer, and your voice coil and your magnet are here, and it loops through the secondary of this is the magnet, but it loops through the secondary, which is also connected in series. So I have a feeling that if I have that backwards, it will have a negative impact on the volume. So I'm going to reverse the secondary of the output transformer and see if that increases the volume. Okay, I think I reduced the volume.
Home equity loan since 1969. Homeowners get approved.
After decades as a school principal, I'm something of an expert in the back-to-school jungle. And one thing I've observed is that in the wilds of the 4th grade...
So we'll switch it back. Let's see if it brings the volume. I think I reduced it a bit by doing that. So the client with this radio wants to replace it with a new transformer. So one thing I need to do before ordering in a new universal audio transformer is I need to determine how many milliamps the idle current is, because the transformer rating is based on how many milliamps are going to be drawn across the winding at all times, because in a single-ended output you've always got current flowing through the primary just to bias the tube. the audio output tube. So there's always going to be 10 or 15 or 20 milliamps, and the size of transformer you want to order is dependent on how many milliamps are going to be drawn through that transformer. If you go too small, the transformer is going to burn out, and if you go to too large, then it's not going to be as efficient as it should be. So how we determine that is we use an ammeter, and in this case I'm going to use the doctor meter because this has got current measuring capabilities. So I've got it in milliamp mode, and I'm just going to break one of the connections going to the transformer here. And we're just going to clip the meter in line. So now this is connected in series with the transformer. So the B plus is going to go through the meter and it's going to come back, and it really doesn't matter the polarity. It doesn't matter. One will show as negative milliamps, reverse it, it'll show as positive. So we'll turn on the power, we'll let the unit warm up, and once the tubes come into conduction, it will give me the idle current. And then I just need to make sure that I order a transformer that has a minimum of what this idle current is going to be. I'm doing this with the volume turned down. Looks like this unit is going to draw about 13.8 or 14 milliamps. So we'll call it 15 is what the idle current is going to be on this one. So I need to order a transformer that is going to have at least 15. So I'm going to go for 30 or 40, maybe even 50 milliamps of current. Now, of course, if I turn up the volume, our DC bias is still going to be the same. In AC milliamp, this will actually measure the amount of current AC wise.
60 or even $600,000.
West Coast Auto presents The Many Sides of Load.
Because that's the audio signal going through.
I say, Captain, mind if I take the wheel?
But in terms of our DC current, it is drawing 17.5 milliamps. So I'm going to order a transformer that is going to be able to handle that amount of constant current. So I'm going to probably go to a 30 or a 50 or whatever I can get in that ballpark without, you know, you got to give some headroom, but you don't want to go too high because going too high is just going to reduce the efficiency. I'm also going to clean the pins of the tubes with some deoxit because I noticed that this one tube here, when I touched it, I got some noise. So this one might not be sitting in its socket very good, but as you can see, there's been a fair bit of oxidation on the pins. So I'm just going to clean a couple of the tube sockets here, or tube pins. We'll do the same for this one here. These metal covered tubes are as rare as hen's teeth.
Not a show, but an appearance.
Yeah, that one's still kind of...
What do you think? I've been on this a few months. I'm like, damn.
I may have to just tighten that socket up below. We'll do that. I'll pull it on its side. And we'll push the pins in a bit on the socket because it appears that that tube socket is not gripping this tube properly.
Nobody punched anybody in the face. That was a good night. That was fun.
Turn the unit on its side. I'm just going to remove the tube here so I can get to the socket below, and then we can just kind of tighten up the pins a bit. I'll show you how to do that. So this one's the socket. Yeah, this wire is just cut there. I realize that. That's that one and the orange wire. This is the electrolytics that I disconnected, so I haven't removed the physical capacitor yet. So you see those wires hanging there, that's just what they are. That's just from this other physical cap that's been disconnected and replaced with the electrolytics. This is the tube socket down here. I'm just going to take my needle nose pliers and I'm just going to give a slight squeeze to each of the pins, slightly, just to increase the tension when I plug the tube back in. This will just increase the grip a bit. And hopefully that'll stop that signal cutting in and out when I wiggle that tube. Okay, the tube goes in with a fair bit more resistance now. Before the other tube, before that, the tube would come out very, very easily. So now there's a bit more resistance. That should give us a much better connection.
You probably had a better setup at Mr. Mo's than you did for that show, though.
No doubt. Bri, you got yourself a smoker. The master of smoker silk, because your recall that day literally is as good,
there,
if not better than mine.
No noise.
Silk, and now there are no more master built smokers. Gina got one and Silk got one.
Bruh.
No more noise when I
called up and he laid that out. So I told
wiggle
that
the
story,
tubes.
And Silk just provided great color and background. That's exactly what happened. He nailed the affiliate that we were on at the time.
And for those who wonder what that cap is,
and we had a local show.
Yes,
some was 2 hours, and one of the
some tubes they use the cap as the anode, like for horizontal output tubes, for example. On these ones here, this should have 4 volts on this one. So there's not high voltage on these, but there can be, because that is connected to an electrode inside the tube. So you gotta watch it if you're working around any tube sets that have got metal caps on them. Don't touch them, because they could have high voltage on them. In the case of a horizontal output tube, it's going to have about 1500 volts on it with the peak to peak on it, right? But it'll have your B plus. It'll have your B plus of on a tube TV of 450 or 430 volts. But with the horizontal output with peak to peak voltage on it, it's going to be well over 1500 volts. So yeah, that'll give you a good one. So you see the metal caps on them, just keep your fingers away. You notice when I was wiggling this, I was keeping my fingers away from the actual cap, even though I knew it was only 4 volts because I measured that before putting my hand in there. But it's a good idea to keep your fingers away from anything metal. So now I've ordered the transformer. I ordered it from Mouser.com, or actually the Canadian version of Mouser. This transformer is relatively expensive. It's going to run just under $100 by the time I get it here. But to the client, he wanted to spend the money on it, so now I'm going to go and get the rest of the caps for it, and we'll change out all the caps on that big multi-stage capacitors mounted in the back. We'll change them out, so this radio will have had all of the electrolytics and all of the paper capacitors replaced, and should be good for, and of course the transformer, and it should be good for many years. So let's get changing those caps. Okay, I have a bunch of new caps to replace the multi-stage cap here. So first thing we're going to determine is the which side the outside foil is on. Although it's really hard to see on the scope because the signal is not picking up much. But there's a little bit more that I can detect. In that polarity there. See? Just see a little bit of a waveform there. It's not much. If I reverse it, so that would indicate that the foil is the side over here. So we're going to replace that first cap in here. The positive is going to connect to here, and the negative has to connect to a ground point, which I can pick up right over here. I think the leads will probably be long enough that if I mount this cap down in here like this, I can do it. So I'm just going to attach the ground wire to this other bare wire here, and that should give me enough lead length that I can attach it where I need to go. Okay, that one is there, and the other side of that one can go right over to the green wire, which I'm going to remove, which I'll just tie it on to this resistor right here, which is also tied down to that same junction point. So we'll just bend a little hook in the end of the wire, hook it around there, and then crimp it on. And then solder it down. And then I can remove the green wire going to the multi-stage cap right there. That one is now disconnected. Oops, that's the wrong green wire. It's the next one. I got to reattach that one. This is the green wire here. That's the one I meant to cut. So I have to reattach this other one that I just inadvertently removed. Now, one of the great tools that we have now that we didn't have before is video. This is a prime reason to always record what you're doing, especially if you're working on vintage devices like this with point-to-point wiring. Is if you inadvertently cut a wire and you don't remember where it went, you can always refer back to the video. The one that I inadvertently cut actually goes to this post here, and of course I can refer to the video if there's any question as to where it came from. I can always refer to the video to verify that I'm going to put it back to the correct point. But that's one of the real benefits to if you're repairing or restoring electronics, especially old vintage stuff, where you don't have a printed circuit board to help you out, because obviously with a printed circuit board, it's pretty easy to figure out where you've taken things off of. But if you're dealing with point to point, like I am, video is an invaluable tool for if you break a wire, or inadvertently cut something, you can review it and see where it went. And I did drop a bit of solder down there, so I just got it won't have stuck to anything though, because it's not, it'll just peel right off. Just like that. No damage. Okay, that's the first of these 4 caps that have been replaced for this multi-stage. We'll replace the other 3 as well. And again, I'll verify the polarity. Even though these are non-polarized caps, I will still refer to the little cheap little DSO that I made, because it seems to do a good enough job, equally as well as my other one, at determining which side is the shield. Here's our ripple, and if I reverse the lead, we have more ripple. See the ripple there? Versus the ripple there. So this side here is our ground. We'll get that out of the way. So there's the 3 that I got to change out next, and they are, one is right down here, the other one is right over here. So I just got to find, there's a ground point right there I can attach it to. So here's the positive side, or the signal side, and the shield is going to go up here to ground for this one. So we'll just, again, bend our little hook in the wire. That one's done. We'll just disconnect this yellow wire going to this multi-stage cap. There, that one's off, and we have another one that goes over to this tube socket here. It's another cathode. These are all cathode followers, right? These caps, they bypass. Look at the schematic here. They are between the cathode and ground. So these are just bypass capacitors. One there, one there, one there, and the last one there. So these are the 4 caps. 1, 2, 3, and 4. So that's the second one done. Third one is this one over here. I just got to find a place to ground it to. It looks like there's a ground point right here in the middle of the chassis. I should be able to. This is the wire here. That's the third section. So I'm connected to here, and the other side of that one. This is a ground lug right over here on this. So let's get that one connected. We'll connect the ground. This is going to be there's bare wires in here, so I kind of have to kind of maneuver this in a way that it's not going to touch anything, but I should be able to get that through there like that and solder it in. Okay, that should be soldered in there good. The other side of that one is going to go down. I'm going to attach it right to this leg of this resistor here. That way it's not going to touch anything else. So we'll just put a little hook in the end of the wire there to hook it around there so that I can tack it down like that. And then once again, I can remove that other wire that's in here. If I can get in there. There we go. That's that one taken out. And we have one more. It's right here. So the last section of that cap is right connected to right here to this tube. I'll just remove this right now. I'm going to remove this this big ugly beast because nothing's connected other than the one lead. So cut off its ground wires. And the last lead for it, I'm just going to leave it a little bit of length there so I can see it, so that this thing is now completely removed. We have this one last capacitor, which is going to go from here to the ground. I can just take it right back to where the other one was grounded to. And that should have all the capacitors in this radio replaced. Then it's just a matter of getting the new output transformer, which has been ordered. As I explained already, the client wants to go with a new universal transformer. So I've ordered one in, and it should be here in the next couple days, but I'm going to get this thing all completely done as far as I can right now, and then I can basically set it aside until the transformer arrives. Okay, that one's attached. The other side of that can go right up to the ground point here. I think I got everything. Make sure nothing else has come loose in the process. That's on there good. That's on there good. Okay, that has it. That's got all the caps replaced on this thing. These wires, these are coming from that multi. I'm just going to stick some tape on them. I'm not even going to bother removing it. It's not going to hurt it sitting there. Leave it there for aesthetics so it looks original. It's disconnected, so we'll just throw some tape around those dead wires. So there's what it looks like. All the caps been replaced. Here's the electrolytic. Second electrolytic is here. And here's all of our high voltage and mild capacitors that have all been replaced. So everything's been done on here. We tightened up the tube socket that was loose. Let's test it. So this is going to be the final test of this radio. Turn on the power. Let it warm up, and this will complete this restoration video, at least this part, because I'm waiting for parts. I'm going to put the thing back in the chassis and just leave it until the parts arrive. There we go. This now completes the restoration video for this 1936 Electrohome AM shortwave radio. We've replaced all the capacitors on it. All the tubes are original, but all the caps, including this ugly multi-stage cap, they've all been replaced, and everything's working. It does not have the correct output transformer on now. The one that I'm running on it right now is one that I took out of my radio. It's actually a push-pull transformer. So I've ordered a brand new single-ended output transformer. It's a universal one, but it should be just fine for this radio. That's coming, and once that arrives, all I need to do is connect it at the speaker. We'll do another real short video to show the radio working in its cabinet when it's done. But I'm going to close it here now because, as you can hear,
29 unanswered points.
As you can hear, this thing,
State in that offense found.
This thing's working fine.
Side investigators say the 18-year-old man shot dead in Abbotsford last night did not have a criminal record. Salvaged Sidhu was shot
for
at 6 o'clock.
what it is, because it's just an AM radio. But anyway,
he was found shortly after.
That's it. Hope you enjoyed the restoration of this 1936 or 37, because they made this over 2 years. But regardless, it's 80 or 81 years old. Very old vintage. Tubes are all still working. New caps. This thing's good for another 80 years. Hope you enjoyed watching this one. And I say we'll catch you later. And I will do a part 3 to this once the transformer comes in, just so you guys can hear it once the speaker's remounted in the cabinet, because that'll make a big difference once it's mounted back in the cabinet. Thanks for watching. We'll catch you later.